Welcome, my friends, back to your channel. Today we are going to continue to talk about virtualization, and we are going to see failover clustering and how to configure failover clustering. But please, before we continue, don't forget to like, share, and subscribe. So why is the need of failover clustering? We talked earlier in virtualization that Hyper-V has what's called Hyper-V replication, where we replicate the virtual machine from one server to another. The thing is that Hyper-V replication requires a human intervention in case of the VM failed. While in failover cluster, this procedure happens automatically. In order to use failover clustering, we must have a SAN storage. This SAN storage will hold the virtual machine's data, and it will be shared among the physical servers. The SAN storage is connected to the physical servers using different types. It may be we may have a SAN storage that connect using SAS cables, or maybe a SCSI cable, a fiber optic cable, or maybe iSCSI cables. I will not go through each type of connectivity in this video. We may talk about that in a video dedicated for the SAN storages, but I will just talk about iSCSI, and I will show you the iSCSI connection. The importance of iSCSI is that it uses normal network cables for connectivity, so companies will not need a dedicated infrastructure for the iSCSI connection. However, for this connectivity to work, the network cards in the servers and the storages, of course, must have what's called jumbo packets, as well as in the switches that will connect the servers to the storages. I will show you now how to put this jumbo packet. As you may see in the video, we go to the network and we we choose the network interface that will be connected to the storage, and then we will go to properties and we will configure it, and then search for jumbo packets, and then we will change the frames from the default to 9014, or maybe in some network interfaces it will be 9000. So how to configure the failover cluster in Windows Server? We will go to Windows Manager, and we will add roles and features. We'll go to Next and choose the server that we want to add the roles. And then, of course, we must have the Hyper-V installed. If it's not installed, we shall install it and add its features. Then we will go to Next, and we will find the failover clustering inside the features. We will choose to install it, to add it to the server, and then we will continue till the end of the wizard. Also, it's important to install to add the feature that's called MPIO, multi-path input output, to the server as well, because we will use it to connect to the storage from different locations. The multipath input output feature, or MPIO, is a very important feature to add to the server that we want to connect to a SAN storage. This MPIO will allow the server to communicate with the storage from different locations, two or maybe more than two paths. This will make a redundancy connection to the SAN storage. In case one of the connection cables get down, the server will still able to see the storage. Now we will go to Windows Server and open iSCSI Initiator. Then we will go to discover the portal. We will add the IP address of the storage, and then we will go to advanced before OK. inside the advanced, we will locate the local adapter where we we specify the jump packet, and we will specify the source IP. Now we will go to press OK, and we will see that the storage is shown. And now we have the volumes that are defined in the storage. They are all inactive, as you may see. We will specify a certain volume, and we will connect to it. Once we connect to it, we will enable the multipath, and we will go to advanced before OK, and then we will specify the local adapter, which is the iSCSI, and the source IP, and of course the portal IP, which is the IP of the storage. We'll press OK, and now we will see that the volume is connected. We will repeat the same steps again on the same volume, because we are going to use MPIO. So we have to connect to the SAN storage from a multipath, and then we will go to advanced as well. And from the advanced, we will specify the other IP of the second iSCSI connection, so that it will connect to the storage from two paths. In case one of them failed, the server will stay connected to the storage. After that, we will go to disk management to find the new volume that we connect to it. We will initialize it, and then we will create a new volume out of it. Now, these steps from the iSCSI connection to the creation of the volume must be done on both servers that will be part of the failover cluster. Now we will go to the failover manager, and then we will start to create a failover cluster. We will specify the servers that will be part of the cluster, and then we may run the tests to make sure that we have all the required features to add the cluster, or we may not. Then we will specify a name for the cluster and an IP address for it, and then we will finalize the installation. Now we will have a cluster ready with both servers, and now we will go to disks in order to add the volumes that we connected using iSCSI. Once we add them to the cluster, they will show in the disks of the failover cluster. We may rename them in order to know which disk for which VM, and the same disks will be shown now inside our C drive, inside the folder called cluster storage. Now we are able to create a virtual machine. From the failover cluster, we go to roles, and to right click, we have to a virtual machine. We may create a new virtual machine. We'll specify if we want to put it in the primary or secondary nodes of the cluster, and which it doesn't matter. Now then we will specify the storage for this virtual machine to be one of the cluster volumes, and then we will specify the rest of the features, and we will finalize to have the VM running. An important note here is that both nodes must be of the same specifications. Otherwise, we may face a problem of moving the VM from one node to another. And the sum of the virtual machine's resources must be the maximum of one node and not two nodes. Which means, if we have, let's say, the nodes that have a maximum of 128 gigabyte of RAM, then the virtual machines that will be placed inside the both nodes may not be the sum of 256 gigabyte. They must have the maximum of 128, of course, minus the RAM of the physical machine itself, which is usually used by 12 gigabytes, which means that we have a maximum of 100 and 16 gigabyte of memory for the total virtual machines that will be installed in the failover cluster. Otherwise, if the number gets exceed the 116 gig, in case of one of the nodes gets failed and the virtual machine starts to move to the other nodes, then some of the virtual machines will not run because they will not have enough resources. Now, what we saw here is what's called one-to-one failover cluster, which means a node and a node that is running and another node that will be ready for the failover. Another thing that some companies will go for another criteria. They may go of what's called, for example, 3-to-1 or 5-to-2. Which means that we will have, for example, if we talk about 5-to-2, we will have 7 servers of the same model. They will hold the virtual machines on all of them, but the sum of virtual machines will have the resources of 5 servers only, of the sum of 5 servers. And in this case, we from the 7 servers, we are able to have 2 servers fail down at the same time, and the virtual machines will still get up and running normally. One final thing to talk about in the failover clustering is what's called a quorum disk or the witness disk. This witness disk is very important to have when you have more than 2 nodes in the cluster. Now, in case we have only 2 nodes in the cluster and one of them gets failed, the resources will move definitely to the second node. But what if we have more than 2 nodes? Then if one of them gets failed, the resources will move to which one of the other nodes. Here the other nodes will do a voting, and here where the quorum or the witness comes along, it will go within the voting procedure to fasten this procedure and help decide which node the resources will move to it. This will be all about failover clustering, my friends. I hope it was clear enough for you. Please don't hesitate to make your comments and ask any question. And please don't forget to like, share, and subscribe.